Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 9-1 Extra Practice Number 2 solutions on finite intuitive limits. For this problem, we have the graph of f, which looks to be some kind of step function, and we want the value of the limit as x approaches 4 of this function. So taking a look at x approaching 4, we always have to look at left versus right behavior. So as x approaches 4 from the left side right here, we're approaching the y value 2. And the right-sided limit as x approaches 4 is going to be 3. Since these two things are not the same, that means that there's no overall two-sided limit, which is what they were asking about here. So that limit does not exist, giving us choice D. For this one, we have a function f that has the property as x gets closer and closer to 3, values of f of x get closer and closer to 5. Which statement is true? So basically, they're talking about a limit here. As x approaches 3, so the limit as x approaches 3 is what this is saying, of f of x, that's the function in question, that limit is going to be 5. As x approaches 3, f of x gets closer and closer, approaches 5. And that's going to give us answer choice C. All the other answer choices were either backwards, or with these f of 3 equals 5 kind of deals, they're talking about function values, which aren't always the same as limits. For this problem, we have a table of values for f, and we want to know which of these conclusions is supported by the data in the table. So as we look at the table here, we're getting closer and closer to 5 from both the left and the right side. That's the pattern they've set up with these x values. So as we get closer to 5, as we approach 5 from the left side, the left-sided limit, you could almost think of this as, it doesn't look like we're really approaching a single y value here. In fact, we keep getting more and more negative. So you might make an argument for negative infinity. Maybe that's up for debate. But definitely the limit does not exist as we approach 5 from the left side. There's no single number we're getting closer to. On the right side, however, as we approach 5 from the right side, the y values are getting closer and closer and closer to y equals 8. So we could make an argument for the right-sided limit being 8. And that would be supported by the table. The table wouldn't be enough to guarantee that the right-sided limit is 8. You can't really guarantee that without a graph or a function, but it would at least support it. And now the two-sided limit, which is also one of the answer choices, well, since one of the limits is DNE, the overall two-sided limit also does not exist. And then there's the other answer choice, choice D, talking about x approaching 8. Well, x is not approaching 8, at least in the values of this table. We don't know anything about 8, so D is definitely out of bounds. But looking at these answer choices, it's looking like answer choice C, right side limit approaching 8, matches what we concluded over here. So choice C. On this problem, we're given the graphs of f and g, and we want the limit as x approaches 4 of f of x plus 6 over g of x. So we need to figure out the limit of f and the limit of g as x approaches 4, and then we can use those values in this overall expression. So taking a look at the f function here, as x approaches 4 from the left and the right side, the f graph is approaching the y value 3. There's a hole there, but we're at least approaching 3. So we can rewrite this numerator as 3 plus 6. Now looking at the g function, as x approaches 4 from the left and the right side, we're approaching the y value 5. So we can write 5 in the denominator there instead of g of x. So this is 9 over 5, which is one of the answer choices, choice C. On this one, we have the f function, this crazy e to the 3x minus 1 over x function here. And obviously x can't be 0 because we have an x in the denominator there. Which of the following equations expresses the property that f can be made arbitrarily close to 3 by taking x sufficiently close to but not equal to 0? So we're basically saying this has the property that as x gets really close to 0, so as x approaches 0, f of x, the y value, approaches 3. This is essentially the idea of a limit. We're saying the limit as x approaches 0 of f of x has a value of 3. So that's going to be answer choice C. On this one, they gave us a table of values for the f function, and they want to know which of these statements down here must be true, and must is the key word on this one. We have to be able to prove this beyond any shadow of a doubt, which is tough with tables. So looking at the table, we have these x values that are getting closer and closer from both the left and the right to the x value 2. And if you look at the y values, from the left side they appear to be approaching 8. From the right side they appear to be approaching 8. So the table definitely suggests that the limit as x approaches 2 equals 8. There we go, x approaching 2, not 1. All right, so this is good as far as it goes. If we wanted to say which statement is supported by the table, then choice B, as x approaches 2, the limit is 8, would definitely make sense. However, they were saying which of these must be true. Do we really know that if we got even closer and closer from the left and the right, that these values are still going to be approaching 8? Maybe they're going to veer off to infinity or something like that. We don't really know, because with a table you don't know any of the in-between values. So there's not enough information here to tell that this is true for sure. We would need either a graph or a formula. So we can't pick B for sure. Now, we also can't say that the limit does not exist. The limit actually could be 8. We can't tell conclusively that this is DNE. And definitely, the table does not support at all the assertion that the limit is 3. But who knows? We can't even disprove this, because maybe if we were to get even closer, we would see the y values were actually approaching 3. But right now, it just looks like they were looking to confuse us with function values versus limit values. So A, B, and C, none of these can be proven for sure. That leaves D. We cannot definitively determine the limit from the data in the table. So we're going to have to go with that one. For this problem, they're telling us that the limit as x approaches 3 of some function is 6. So which of these could be the graph of f? So there's a lot of different possibilities of graphs that have a limit of 6 as x approaches 3. But let's take a look at each of these and see what the possibilities are. So taking a look first at choice A, we see here that the limit as x approaches 3 from the left and the right side are different numbers. We've got 4 versus 6. So the overall two-sided limit, which is what this is talking about, does not exist. On to choice B, as we approach 3 from the left, we're going to 4. From the right, the limit is also 4. 4 is not 6. It's a number, but it's not the one we wanted. So B also is no good. Choice C, from the left and the right side, we are approaching the value 6 as x approaches 3. So that looks like a pretty good answer choice, but let's take a look at D to be on the safe side. Choice D, from the left and the right side, we appear to be approaching the y value 2. So again, not the number we wanted, so choice C it is. On this problem, we're given a table of values for f, and based on the data in the table, we want to know which of the following couldn't be the graph of f on this interval. So this is going to be one of those pick the best answer kind of things. Looking at our table here, it looks like as we approach x equals 3 from both the left and the right side, we appear to be approaching the y value 3 as well. And it's also interesting to note that we're approaching the y value 3 from above from the left side and also from above from the right side. So taking a look now, so in general our table suggests that our limit as x approaches 3 of f of x is also 3. Taking a look at the graphs that match that assertion, choice A, definitely the left and the right side limits appear to be 3, so that one's good. Choice B, the limit is also 3. Even though there's a hole there, we're still approaching the y value 3 as x approaches 3. Same thing on choice C. This dot here doesn't really alter where the limit is. Choice D, however, as we approach from the left side, we have a limit as x approaches 3 of 2. And that's not going to do it. We would need 3 from both sides. So out of all of these, D is the best one to choose here. It's the least supported by this table. On this problem, we're given this graph of f, and we want to know which of these expressions down here has a value of 2. So we're going to take a look at function values and the left and the right-sided limits. Let's take a look at choice A, f of 6 first. So f of 6 is just going to be the solid dot when x equals 6. Looking at our graph, that solid dot happens at y equals 4. So that's not the answer we're looking for. F of 6 is 4, not 2. Next one, we have the left-sided limit as x approaches 6. So approaching from the left side here, we're approaching the y value 2. which makes this a pretty good answer choice because 2 is what we wanted. But let's look at the others to be safe. Choice C, approaching 6 from the right side, so that's approaching from that direction. That gives the y value 6, which is not what we wanted. And then finally, this is the two-sided limit as x approaches 6. Since the left and the right-sided limits don't match, the two-sided limit doesn't even exist. So that's pretty far from equaling 2. So out of all of these then, choice B is the best answer.